Have you ever been playing an idle game and you were like, wow, I really wish this had accurate physically correct shadows? Yeah, me neither. But I wanted dynamic lighting for my 2D idle game. So I decided it would be a great idea to spend the next few months figuring out how to do that. Was it a complete waste of time? Yeah, probably. But it looks like really good. The thing is, shadows aren't just decoration. They make objects feel like they exist in the same space, interacting with each other. Without them, everything just kind of floats. In 3D games, this is easy. The engine just handles it for you. But in 2D, not so much. So my goal is simple. I want shadows that accurately interact with the world. They should wrap around objects, respect height, and even affect each other. The problem is, I had absolutely no idea how to make that work. So I started with the simplest thing I could think of. But first, some huge news. Idle Fisher now has a public demo on Steam. If you're looking for a fun idle fishing game, you should definitely go check it out. And if you like it, leave a review and wishlist the base game. It really helps. If you don't like it, leave a hate comment back here on YouTube. While you're down there, hit subscribe since over 90% of you aren't. Thanks in advance. Alright, shadows. The most common way to fake shadows in 2D is super simple. You take the sprite, squish it, add a little distortion, darken it, done. And the code for this is actually pretty straightforward, or at least my version is. Now for every image, I'm testing if it should have a shadow. If it does, then I draw the base image again, but this time through the shadow shader. Inside of the shader, I'm setting the top left and right points to half its size, then moving it along the x-axis by its height. I then offset the top right and bottom right points, otherwise the shadow looks very squished. It's a pretty hacky solution, but it works for now. And inside the fragment shader, I'm just getting the alpha and halving it so we have a nice semi-transparent shadow. Let's see what we've done. This is definitely an interesting result. I will say at a quick glance, it kind of looks good, especially the trees, the character of the NPCs, and the pet shop. But no matter how fast you glance at that picnic table, nothing's making that look good. The more I look and walk around, I start to see that there's a bunch of problems telling me I'm still pretty far away from perfect shadows. They're stretching in weird ways, showing up underneath objects, sometimes even in front of them. The character is either fully in front of the shadows or fully behind it, never really interacting with it properly. So I wanted to understand what was actually going wrong here, so I opened up my favorite debugging tool, Photoshop. I started manually tweaking the distortions to see what should look correct, and that's when I noticed a pattern. Thin objects, like the trees, actually worked really well, but larger, more complex shapes, especially buildings, are a lot harder to get set up correctly. And even if I somehow fixed all of that, there's still a bigger problem. These shadows don't actually wrap around anything. They just sit there in front of other objects, never really interacting with the world. And for all of you screaming through your monitor for me to just manually shade in the image, no, that wouldn't be cool, and I'd be out of a video. At this point, I'm starting to think that this method isn't going to cut it. So my next idea was, what if I just fake 3D? Take every sprite, stand it upright into 3D space, and let a real shadow system handle it. Already, it looks a little weird, but let's try it out for now. Let's start by getting the buildings to stand up. I check to see if the object should have a shadow, and if it's again the top left or top right vertex. Then set its depth depending on the image's height. Depth ranges from 0 to 1, but the light uses its own range. So I remap the value to fit. Then simply make the vertices Z position equal to the depth value. And just a quick check to see if it works, inside the image's fragment shader, I've set the color to the depth value. Perfect. You can see exactly how each image's depth changes the same amount. For the shadows, I found a really common technique called shadow mapping. But the idea is actually pretty simple. You render the scene twice. First, from the sun's perspective, which gives you a depth map, where closer things are darker and further things are lighter. Then you render the scene normally. This time, for each pixel, you check, is it further away than what the sun saw? If it is, it's in shadow. This might sound complex, but it's actually pretty simple once you break it down. First, we render the scene from the sun's perspective. Instead of drawing to the screen, I just send everything to a separate buffer, and view the world from the light instead of the player. Then I just draw the scene like normal. The result is a depth map that looks something like this. Not the prettiest, but it's working, I think. Now for the second pass. This time we render the scene normally again, but we also pass in that depth map we just created. The real work happens inside the shader. In the vertex shader, I convert each vertex from world space into the light space. Then in the fragment shader, I take the position, map it into 0 to 1 coordinates, and use it to sample from the shadow's map. Then I compare the current pixel's depth to what the light saw. If it's further away, it's in shadow. I also add a small bias here, just to prevent the surface from shadowing itself. That gives me a shadow value, 1 if it's lit, and something darker if it's in shadow. Then I multiply that with the original texture. Wow, this looks pretty bad. Looks like the shadows are hidden in one of these. Okay, let's just try to ignore the problems for now and see if the distortion part actually works. Oh, and I'm drawing behind the building. Okay, maybe something simpler. The rock? Ooh, okay. That's working nicely. But why am I drawing behind the building now? Looking at the depth map, something's weird here. No matter what object I look at, whether it's the rock or the building, the gradient looks exactly the same. It's like the system doesn't actually care about the shape of the object at all, which means I'm not really testing against the actual base of the building, but rather the flat bottom of the image, which is why at certain points the shadow just stops warping entirely. The system understands that the building is separate from the ground, but everything on the building is still flattened together. I wonder if I could break each column of pixels into its own image and give it some depth for the shadow system, but this would require hundreds if not thousands of images, an interesting idea that I might come back to later. So at this point, I thought, fine, I'll just go full 3D. I started modeling out a very basic version of the fisherman's house just to see if it even worked. Then I wrote a model loader, brought it into the game, and did the same for the character, just syncing up the model to the player's position. For the shadows, I reused the same shadow mapping technique from before, and after setting that all up, it actually works, like really well. All the problems from before are gone. The shadows wrap properly, there's detail on the windows, the door frame, even the roof looks right. But there's something you've probably already noticed. The shadows don't line up with the pixel art. No matter what I tried, breaking the model into smaller pieces, tweaking geometry, anything, I just couldn't get them to match. And at that point, I hit a wall. After months of work, switching graphics APIs, remodeling my whole engine, and trying all these different methods, not being happy with a single one, I was at a loss. I was completely out of ideas for how I could accurately get shadows to work in 2D. I started to think it was impossible. I spent countless nights trying to think of a solution and eventually gave up. I moved on and started working on other things like the water, more updates, or even other projects. I thought I would have to scrap this whole video. Until one night, during the time I was working on the demo, I tucked myself into bed and thought, how cool would it be if I can actually get shadows to work? So I went back through each of my old ideas, not just trying a new solution, but really thinking about why the old ones failed. Eventually, I made it to the standing sprite method. That's when it clicked. It didn't work because the sprites were still 2D. Sure, I could try splitting each column into its own image and giving it depth, but that's not enough. Each column would keep things like the roof and the window frames at the same depth. To get the detail I wanted, I'd have to separate each pixel. Even just the fisherman's house alone would require around 24,000 images. Not exactly practical. Then it hit me. If I can't break objects into pieces, maybe I don't need to. Maybe there's a way I could tell each pixel its depth. That sounds familiar. It's basically what shadow mapping does. We're definitely getting closer, but there's still a few things I need to iron out. To start, shadow mapping uses the camera's perspective to output the depth map, which is a bit of a problem. Actually, two problems. First, I'd have to draw from a perspective that I can't even see, which is already a nightmare. I guess I still have my 3D model from earlier that I could use as a reference, but it still wouldn't be very fun. But the second and much bigger problem is that every time the camera moves, the depth map would have to change. And since in 3D, the process is practically automated, you can't really do that in 2 dimensions, meaning I would have to manually draw thousands of depth maps, which would be very close to impossible. The other change I would have to make to the shadow map technique would be what I draw black and white. What I mean by this is in the shadow mapping approach, the objects that are really close to the camera are very dark, and the further objects are very light. Attempting this, I ran into a problem. It's extremely hard to draw. And layering this on top of drawing from a different perspective is, I don't think, humanly possible. So I put this idea on hold and again started to think back to other solutions, until I remembered that recently I made a ray tracer. In ray tracing, rays figure out that they're in shadows by drawing a direct line from their start location to the light source. If a ray hits an object on the way through, then it's in shadow. I thought to myself, how does this help me? Well, all a ray needs is a start location and the direction to the light source. So in theory, if I had the pixel's location in world space and paired it with some sort of line cast function, that would be enough to make shadows. This actually gives me a really good idea. Do you think I can make a 2D ray tracer? And no, I don't mean one of these. I mean like a full-on 2D isometric ray tracer with reflection, shadows, and more. Comment down below if you think that would be a good idea. I might save that for a rainy day. Finally, after fully thinking out the whole method, I went back and tried to think of ways to break it, using problems from the previous methods to new ones. After brainstorming for a while, I couldn't think of a single one. I thought this was finally the method that would work perfectly with my 2D game. But unfortunately, like I said, this was when I was developing and finalizing the demo. At this point, I still had a month or two before it was finished. I wrote all of my ideas down and was very eager to start development, so I stashed them away till after I published the demo, as I didn't want to delay its release any further. Which brings us to now. After finally publishing the demo, I can work on shadows, to see if this long-awaited idea even works. So I opened up my Notes app and started with this location image. At first, I stored everything in RGB, X in red, Y in green, and Z in blue. Here's the result of 10 whole minutes of work. I know, there's like 14 pixels on the screen. It's too tiny to see anything. So I went ahead and made a bigger example. This looks pretty cool, but with how long it took to draw, I'd say it's very impractical. On top of that, I realized that I was getting close to running out of color to draw with. Since this almost happened on the fisherman's house, and the map is way bigger, there would definitely be some problems. Luckily, while drawing the image, I realized something. If I separate out each of the color channels, there's something interesting that happens. Starting with the X channel, it's a simple gradient, starting at 0 on the far left and going to the width of the image, which isn't really giving me any useful information as I already know the X position, so we can get rid of it. Now we are left with the Y and Z. Y is the height of the pixel, how far up in the world it is, and Z is its depth, where it sits along the ground. But then I realized, I might not need to store the Z either. If I take a pixel, I already know its position relative to the image, and I know its height from the Y channel. So if I just move it down by that height, I land exactly where the pixel touches the ground. The new position on the image is actually the Z value, which means I don't need to store the Z channel either. And just like that, everything collapses down onto a single image. At this point, it's still stored in the green channel, but it's really just one number per pixel, so I convert it into a standard grayscale image where black is low and white is high. This might start looking pretty familiar to some of you. We're pretty much left with what's known as a height map. A quick side note, this height map does have a small problem, that if I ever make a building past the 255 build limit, I'll run out of color data. But luckily I checked and everything is shorter than that. I also have some ideas in the case that does happen, but I won't bore you with them now. Apparently, height map shadows already existed, something I didn't know until the making of this video. Doing some research, I found that this guy did something similar a few years ago, but he wasn't stupid enough to draw his own height map by hand. Now that we have a basic understanding of how the shadows are going to work, let's start making them. First is getting the height maps to draw on top of the actual map. So in the images constructor, I've added a hash shadow variable. If the value is true, I will load the shadow variant of the base image, which is simply the path with height map attached to the end. Then in the draw function, I'm drawing the shadow texture using the shadow shader, which as of right now is the same as the default shader just for testing purposes. The key difference is that I'm drawing it to a different render queue. Essentially, I'm telling the shadow images to go sit and wait in a line while the other images are drawing. Then at the end of the frame, I draw all the shadows, which puts them in front of all the other objects. Running the program again, we should hopefully have a very gray fisherman's house. Great, it's working. I'm drawing behind the building, but that's expected. Okay, now the long-awaited shadows. The idea is actually pretty similar to ray tracing. Normally, you'd shoot a ray from a point towards the light and see if anything blocks it. But in 2D, we can't really shoot rays like that. So instead, I use something closer to ray marching. Here's how it works. We start with a single pixel on the map. This is the point we're trying to figure out. Is it in shadow or not? From here, we step towards the sun, 1 pixel at a time. And at each step, we ask, is the point high enough to block the light? Let's look at a simple example. Imagine a pixel sitting right on the surface of the ocean, so its height is 0. Now we start walking towards the sun. After 1 step, after 2 steps, after 3. After each step, the required height to block the light increases. So if we've taken 5 steps towards the sun, the terrain at that point would need a height of at least 5 to block the original pixel. And if we ever find a pixel that's tall enough, that means that the light is blocked and the original pixel is in shadow. If we have something like a tower of pixels, then you could see how after checking each one, you get a nice shadow effect like you'd expect. Now inside the fragment shader, I hard-coded the direction of the sun, just to keep things simple for now. Then I define a few important values, a bias and a margin. The bias is there to prevent pixels from shadowing themselves. The margin is a bit different. It gives me some wiggle room, so instead of requiring an exact height match, I allow a small range. Then I grab the starting height, which is just the value from the height map at the current pixel. And I set up a location variable, which I'll use to walk towards the sun. After that comes the main loop. This is the ray marching part. I cap it at 150 steps, just so we don't check forever. Each step, I move the position towards the sun, round it to the nearest pixel, and calculate the height that would be needed to block the light. Then I sample the height map at that position and compare the two values. If the terrain is within the margins, meaning it's close enough to the required height, we consider the light blocked, and mark the pixel as shadowed. Otherwise, we just keep stepping forward until we either hit something or run out of steps. Let's try running the program again. We'll surely have beautiful shadows. Wow, this is like really good. Everything seems to be shading itself perfectly. The roof is shading the wall, the jet out is blocking this wall, and even the little chimney is shading in the roof. Player's drawing behind the shadows, but I don't even care right now. This is looking really good. Hold on, I want to try something. I'll map the direction of the sun to my mouse position. Let's see what happens when I move it around. That's pretty cool. Good morning. Good night. Oh, the sun can shine from below the world. Interesting. Hold on, should probably give this thing a floor first. Otherwise, there's nothing for the shadows to actually land on. Perfect. There we go. Much better. Okay, there's still one big thing missing. The character. I mean, this is kind of the whole reason I started this in the first place. To make him feel like he's actually in the world. So let's start by also giving the character his own height map. But what color do I start the height map at? I mean, looking back at the map, the terrain isn't flat. Different areas have completely different heights. For now, I just picked a value that matches the dock, and built the rest of the height map upwards from there. I knew this would cause problems later, but I'd figured I'd just deal with that when I got there. Then back in the game, we'll simply just draw it on top of the other height map. But this time it's actually not that simple. If we just draw the image like we have now, in the height map view, it looks like it works great. But in the shadow view, it looks like it doesn't even exist. After a little digging, I realized that the shadow shader runs per image, so it has no way of affecting other objects. So instead, I combined everything into a single height map, and just like that, it worked. The character could finally cast shadows properly, and actually interact with the world around him. Now that I know this method works, I spent the next several days making this. To be honest, I'd much rather watch paint dry than ever do this again, but at least I think it was worth it. Let's just take a second to really admire the shadows one more time, now that we have the character working too. Yep, this is what I thought would happen. I'm flying. Whee! So depending on where I stand, the character can end up floating. So I tried a different approach. Instead of baking in the height, I rebuilt the character's height map starting at 0, and then sampled the terrain underneath the character's feet, adding that value back in. And it mostly worked. Walking across the upper and lower part of the dock worked pretty well. But I noticed a slight problem when walking between the two. The character was constantly jittering, bouncing back and forth as I moved up the steps. So I took a closer look at what the system was actually reading. And looking back at the height map, it makes sense. There's a lot of small detail, especially around the stairs. The character's height map was being pulled from tiny gaps and edges instead of a stable surface. So instead of using the main height map, I made a second one. This one is much simpler. Smooth transitions, no small details, just the general shape of the terrain. And thankfully, this one only took about 5 seconds to make. Now when I sample from this map instead, the character moves smoothly between surfaces without all the jitter. Alright, the shadows are looking pretty good now, but there are still some things that just feel off. Like right here, the trees don't look great. Not the shading on the trees itself, but the shadow it leaves behind. And it's not just trees. The mechanic house does it too, and the auto fissures. There's some weird, unfinished look to the shadows, like something's missing. At first I got really worried that something was wrong with the whole height map method. But after coming so far and being so close to a finished product, I didn't want to just give up yet. So I went back to the height map view to figure out what was going on. Take the auto fissures for example. If you think of it like a box, the system actually understands a few sides pretty well. The top, the left, and the right. But that's only half the shape. What about the back left, the back right, and the bottom of the object? The system has no idea that those even exist. So when the shadows get cast, it ends up looking really flat. So I tried to fill in the missing pieces. Instead of using just one height map, I added a second one, specifically for the back sides that were missing before. The first map handles the front-facing geometry, and the second one fills in what's behind. Implementation-wise, it's actually pretty simple. Each object can optionally have the second height map. And back in the image's draw function, if it does, I render it into a separate behind shadow layer. Then both layers get passed into the shader, and during the shadow check, I just test against both of them. And for the result, here's the before and the after. It looks a lot better. The shadows feel way more complete, like the objects actually have volume now, instead of just being flat cutouts. There is one last problem I ran into. Right here. The shadow just disappears, like it never existed in the first place. And once I started looking for it, I noticed it happened everywhere. Especially in areas like this, where objects overlap. So I dug into what was actually causing it, and turns out the problem isn't the shadows itself, it's the height map. When I draw the tree, it overrides the depth information underneath it. So when the shadow system runs later, the original data is just gone. My first idea was pretty straightforward, just give the character his own shadow layer. And that does fix the issue for the character. But then I started noticing the same problem with other objects. Like this tree cluster. The tree in the back almost loses its shadow entirely. And at that point, the solution starts to fall apart. Because now I need a separate layer for every object, which means more textures, more passes, and a lot more computation. I haven't found a clean solution for this yet that doesn't completely tank performance. Luckily, it's not super noticeable most of the time. So for now, I'm calling it good enough, but it's definitely something I'd like to come back to later. Alright, that pretty much brings me to the end of this. And honestly, after all of this, I'm starting to realize something. I probably could have just made everything in 3D and used some kind of post-processing to make it look pixelated. It would have been faster, easier, and probably would have solved a lot of these problems. But I don't think it would have been nearly as interesting. I still have a bunch of ideas I want to try with this, especially around performance and fixing some of the edge cases, so I might come back to this in the future. And if you haven't checked it out already, Idlefisher has a public demo on Steam. If you try it out, I'd really appreciate it if you left a review. And also leave a comment down below telling me your specs and FPS. I haven't tested it on many systems yet, so I'm curious how it runs for you. Anyways, thanks for watching, and I'll see you in the next one.